Good morning, dear students. Today we will start some more questions and we will solve some more questions on properties of determinants. So, first of all, we will take example of this question. This is equal to delta equal to x plus y plus z and z plus x, z x y 1 1 1. This is your determinant, and we have to prove this determinant as equal to 0. So how we can use this as 0, we will see that. Furthermore, applying r1, that goes to r1 plus r2 to determinant, so we get delta or determinant equal to x plus y plus z. Here also x plus y plus z, and here also x plus y plus z, and second row we have z x y, and here we have 1 1 and 1. So taking common from r1 xyz, we have, this is the determinant, you can see it. Okay, taking common from r1, and what we are taking is x plus y plus z, and it will become 1 1 1. This is z x, and y, this is 1 1 1. So this is our determinant, and by using the property that if two rows or two columns are identical, definitely the value of determinant is 0, hence proved. We will see some more questions, and the question can be evaluate determinant, that determinant is 1 1 1, a b c, and bc ca and a b. For the solution of this question, we'll solve further. Applying R2, that is R2 minus R1, and R3 goes to, that is R3 minus R1. We get we get delta or determinant is equal to 1 0 0 A, B minus C, C minus A, then it will be C, C, A minus B, and B, A minus C. Determinant is this one. We will get this as our determinant. Furthermore, taking common, taking common from row to BA, B minus A, oh minus E, this is BA, 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 okay. Taking common B minus A or A minus B, whatever you want to take, you just take it. Taking common B minus A from the R2 and C minus A from R3, we have delta is equal to, or determinant is equal to, B minus A and C minus A. Then determinant will become 1 0 0 A 1 1 B C minus C minus B. This is our determinant. Okay. So further what we are doing is just expanding this determinant along C1, that is column 1. We will be having B minus A, C minus A, then 1 into minus B, minus of minus, plus C, expanding along first column. Then it will become B minus A, then C minus A, and it will become C minus B. Or we can also do taking common from taking common minus 1 from here and here. We will be having A minus B minus, then I am writing this one first, so it will become B minus C, again minus, so plus sign, and C minus A, obviously. So definitely this will be your answer. We'll move to the next question. Prove that prove that determinant b plus c, a, a, b, c plus a, b, c, c, a plus b is equal to 4abc. 4abc. We need to prove this. So, on solving this, taking left hand side LHS, determinant equal to, we have b plus c, a, this is b, c plus a, b, and c, c, a plus b. On applying, we have to operate this for from property of using the property. We can apply r1 goes to r1 minus r2 minus r3. This operation we have to put it here. Then determinant will become 0 b c minus 2c, c plus a, and c minus 2b, b, a plus b. If we expand, then after expanding along r1, we will be having determinant equal to 0, this into c plus a, b, this is c, this is a plus b. We know the rule of that. Then this will become minus of minus 2c, determinant will become b, b, c, a plus b, and plus minus 2b, determinant will become next b, c plus a, c plus a, this is c, this is c. Now solving further, determinant equal to 2c ab plus b square minus bc minus of minus, it will become plus. So yeah, 0 multiplied by anything will give you 0, and minus of minus will give you positive sign. Further, minus 2b bc minus c square minus ac. We have this one. Okay. Further, on solving this, we can have this one 2 a b c plus 2 c b square minus 2 b c square. This is minus 2b square c, minus minus plus, it will become 2bc square, and minus minus again plus, this is 2abc. So we can see here we have uh, this 2abc, and here we have 2abc. This will give you 4abc. Before doing that, we will see that what we have or what we don't have, and how we are going to cancel these terms. 2cb square, this is positive sign, and this is negative sign, minus 2b square c, so we can cancel it, and this is also get cancelled. So what we have is 2 plus 2 we have equal to 4abc equal to RHS, hence proved. Okay, we'll see some more question. You need to solve all the questions, therefore I am solving these questions for you people, and you just go with me and solve along with me. You can, or you will be able to solve all the questions while watching the video itself. So next question is, if x y z are different and delta or determinant is equal to 0, then we have to show that 1 plus xyz is equal to 0, or I'll write it first. xyz are different. X, better I use some different ink, this one. Okay, x y z are different, different, and determinant is x square 1 plus x cube, y square 1 plus y cube, z square 1 plus z cube is equal to 0. Then we need to prove or show that 1 plus x y z is equal to 0, or we can also prove that x y z is equal to minus 1. This is also a favorable thing, we can also prove that definitely. Okay, so what we have is this determinant is equal to 0. This is a kind of equation form. It we have to use these two things, left hand side and right hand side, together to solve this question. Okay, so this is, I'm directly jumping to the solution. This is our determinant. Now we can split it using the property that if it is sum of two or more terms, then definitely we can write that much of different or separate determinant. So I can write it as x square 1, y square 1, this is a square, Okay, z z square 1 plus x or y z, I am writing it column wise, x square y square z square, and the next column we have x cube y cube and z cube. Using the property number 5, we have this one, you can see it. We can have further, uh, we can change this, we can interchange the column c2 and c3 and also c1 and c2 twice. If we do that, definitely there will be no changes in the sign, as we know that if one time, if anyone changes rows or columns or interchange rows or columns one time, then minus sign will be there, and twice again, so we will see that minus 1 इंटू यहाँ पे क्या है, C3 एंड C2, C3 and C2, and we will do that only. C2 and C3 we are changing, so it will remain the same, x y z. Instead of C2 we are writing C3. So C2 is x square y square z square, and C3 is 1 1 1. So we will change this one, so it will become 1 1 1. Now it will become x square y square and z square. Similarly, if we take a common x, y and z from the r1, r2 and r3 respectively, we have x, y, z, and we have 1 1 1. This is x, y, z, and this is x square y square and z square. Okay, we have this one. So here we are. Okay, I'll change this one again, that c1 and c2. I'm interchanging this column 1 and column 2. We have column 1 and column 2. We have 1 1 1. This is minus 1. Already I had minus 1, and now this time again I have, so this is minus 1 square x y z, x square y square and z square. This is y plus x y z 1 1 1. This is x, this is y, this is z, this is x square, this is y square, this is z square. Taking common this determinant, as we are having the same determinant, therefore we can write this is equal to 1 1 1 x y z, x square y square z square, and 1 plus x y z. Furthermore, using R2 application, that applying in this determinant only, okay, I'll write it first. 1 plus x y z, or first I write the this one, right? Applying R2, R2 goes to R2 minus R1, and R3 goes to R3 minus R1. Then determinant will become, or I'll write this one as equal to 1 plus x y z, 1 0 0. This will become x, and this is R22 will become y minus x, R32 will become z, my mistake, it's not R23 or 22, it's a element or a small letter a, 22 or small letter a, 32, z minus x. Then the third column will become x square y square minus x square, and this will become z square minus x square. Now the determinant, by seeing this determinant, we can observe that here here or here we can take common y minus x, and here z minus x. In this R2 and R3 we can take the common. So what we have is 1 plus x y z, 1 plus x y z, and it will become y minus x and z minus x. Will be having our determinant as 1 0 0 x x square, and this will become 1 1, and this will become y plus x, this will become z plus x. Expanding along C1, that is first column or column 1, we have 1 plus x y z, y minus x, now this will become z minus x, and this will become z minus y, expanding along C1 or column 1. Since delta is equal to 0 and x y z are all are different, and definitely we cannot say that or all are different. X, y and z are different, so x minus y cannot be 0, z minus x or x minus z cannot be 0, and z minus y cannot be 0. So if determinant is equal to 0, then if all are in multiplication or in the form of factors, so it must be 1 plus x y z equal to 0. Hence proved. It must be 1 plus x y z is equal to 0. Similarly, you can solve all the questions in the exercise. Exercise 4.2, you need to solve all the questions you will be able to solve. I have shown you some examples of questions how to solve the determinants. Now we will be moving to the next topic, that is area of a triangle. Area of a triangle. Area of a triangle. So this is the one of the application of determinant, or by using the determinant we can or we will be able to find the area of triangle. So if there are three vertices in a triangle that is given to you as x1 y1 vertices, and next word is x2 y2 and x3 y3. This is the vertices of triangle, it is given to you. Then definitely you will be having a formula with you to find the area of triangle is or that can be expressed in the form of 1 by 2 x1 y2 minus y3, this is 3, okay, plus x2 x2 y3 minus y1 plus x3 y1 minus y2. This is the formula we know to find the area of triangle if three vertices is given to you. Now this expression can be written in the form of determinant also as determinant equal to half x1 x2 x x3 y1 y2 y3 1 1 1. This is the determinant where you can solve it to find the area of a triangle. One should remember this, since area is a positive quantity, we always take the absolute value of the determinant. So for that I'll put determinant absolute value. this is mod of the determinant. This will give you positive value only, where you are going to calculate the area of determinant, or sorry, the area of triangle using determinant. One more thing, note it down, that if area is given, then use both positive and negative values of the determinant for calculation only. And next note, you can have the area of a triangle, the area of the triangle formed by three collinear points is 0. We know that while solving in previous year, we have seen that collinear, this this is the one single line, this is one of the point, this is one of the point. uh, I'll take some different color. This is one of the point, this is one of the point, and this is one of the point. Let us assume this is the point where I am crossing, and see, this is point A, this is point B, and this is point C. Then definitely these 3 points are collinear, and we need to prove that we will be having uh, 3 or 4 methods to find out how uh, we have we have seen to find the collinear by using 3 methods, as one is slope method, another one is distance method, and the last one we use to find the area of triangle of that. If area of triangle formed by these 3 points is equal to 0, then definitely you can say that these line are these points are in collinear. So collinear points is 0 when the area of triangle is formed, and area of triangle formed, that is equal to 0. Okay, we will see some example to solve how we are going to solve this one. So question says, find the area of the triangle whose vertices are 3 comma 8 minus 4 comma 2 and 5 comma 1. The area of triangle is given by, definitely we can calculate the area of triangle, that is delta equal to half, this is 381 minus 4 2 1 and 5 1 1. We can frame it like this, and we can calculate this one. And how we can calculate? We can expand this. And how we can expand? We can expand through R1. We can use it R1, or you can use the properties, so that you can make this and this as 0. Definitely you will be having very less number over here. You can use the property also to make this to 0 and this one to solve. So what we are doing is we are just expanding this one 1 by 2, and this will become 3. 2 into 1 will give you 2, and 1 into 1 will give you 1, minus 8. Minus 4 into 1 will give you minus 4, and 1 into 5 will give you 5, and this is 1, so plus 1. Minus 4 into 1 will give you minus 4, and 2 into 5 will give you 10. Furthermore, this is 1 by 2. Already we have 2 minus 1 will give you 1, and this will become 3 into 1 is 3. Then minus 5 minus 4 will become minus 9. Minus 9 into 8 will give you 72 plus 72. Then here we have minus 10 minus 4 will give you minus 14. On solving this expression, we have 61 by 2 square unit. Find the area of triangle. Questions is saying that area of triangle. If we require to find the area of triangle, always mention square units. Though unit is not given to you, you need to write square units. Okay, we'll move to the next question. We'll see one more question. Find the equation of the line joining points. That point A is given as 1 comma 3 and point B that is given as 0 comma 0. Using determinant and find k if point D has its coordinate as k comma 0 is a point such that area of triangle ABD is 3 square units. Area of triangle area of triangle is equal to 3 square units. The question says, I am reading it once again for you. Find the equation of the line joining A 1 comma 3 and B 0 comma 0 using determinants and find k if D of k comma 0 is a point such that area of triangle ABD is 3 square units. Let us assume a point P, that is x comma y, solution. This is solution. Let us assume point P, that is x comma y, be any point on AB. This is on point A or line AB. Then the area of triangle ABP is equal to 0. Area of triangle is equal to 0. Why? Because these is collinear points. These are collinear points. That's why the area of triangle is equal to 0. So further we can write, we have point A, we have point B, and we have point P. So we can write area of triangle half 0 0 1 1 3 1 and x y 1 is equal to 0. We have seen that this is equal to 0. So further expanding through R1, we have half y minus 3x equal to 0, or we have y equal to 3x. This gives y equal to 3x, which is equation of required line AB. This is the first part of the question. Now moving to the second part of the question, we need to find the value of k, and for that what we have to do is, again we will frame a determinant. The area of triangle ABD is 3 square units we have. So half 1 0 k and 3 0 0 1 1 1 will give us plus minus 3. In the note I have described that if area is given, use both positive and negative values of the determinant for calculation, I told. So we will use plus minus 3. Now on expanding, using C2. Why C2? Because it has maximum 0, or you can use R2 also, it has maximum 0 over there. So we need to do that only. So this is the determinant, and expanding through this is by R2 or C2, we will be having expanding through R2. Let us expand through or along R2. We have half and leave this R2 and C3. We have 1 3 k 0. This is equal to plus minus 3. So half 3k minus 3k equal to plus minus 3. So now it will become minus k equal to plus minus 2, or k equal to minus plus 2. This is the value of 2. This is the value of k. So we have solved our question, that to find the equation of line AB, and also we have found that value of k. So this is the final answer. Okay, by using these methods you will be able to solve exercise 4.3, and this is your home assignment, that you solve all the questions in exercise 4.3. For today, this is for now. Thank you. Have a nice day ahead.